Okie dokie. So we're back. Hopefully you've had enough practice. You feel confident that, especially those 13 to 16s last day, those are hard. And I know the answers are in the back, but figuring out that kind of stuff is difficult. And today we're going to throw one more wrench into the situation with we're going to talk about concentration and how that fits into our stoichiometry and mole map. Again, pages 129 to 130 is sort of what I'm doing, and then we'll do the exercises from there. Okay, so the concentration people have trouble with because they have trouble sticking it into the mole map. And even, at the beginning I sort of said, oh, density doesn't fit in the mole map, but it actually does. Everything fits perfectly into the mole map. But when you look carefully at the way the book solves these problems, it does not use the map the same way I do. So it does it in 2 steps. But it's very powerful having that mole map in your use, because you can do everything you want in 1 step. But sometimes it's hard to figure that out, and you would just want to use 2 steps, and that's fine. But just as a reminder from yesterday that with our mole map, that you can use 22.4 moles per liter if it's a gas and an STP, but other than that, you have to use concentration, right? And so there's a pretty darn important bridge between volume and moles that is concentration, and we are going to be using concentration today and fitting that into our stoichiometry. So remember too that you can solve for a bridge. Like when it asks for density, you have to surround that density bridge. I'll show you that in a minute here. So again, when you are asked to solve for density, you have to first find what's the mass and what's the volume. And you could find those from separate places. Like it could just say, oh, here's a certain number of moles and there's the concentration, or hey, here's a certain number of moles and in this, or you could use the molar volume. But you've got to surround the bridge in order to calculate density. Well, it's the same thing for if you're trying to figure out concentration. So some of these problems are going to ask you for the concentration, in which case you need to know the volume and you need to know the moles. Again, the volume, unless you're given the density, it's probably going to give you the volume. If it gives you the density, then you could figure out the volume by sort of going around the concentration bridge. But you need to, the volume is usually going to be given to you, but the trick is finding the moles to surround this bridge. Where does this moles come from? Well, if we back up, that mole could come from anywhere here. So if you're trying to look for this mole, it could give you this, well, yeah, it could give you that, but you probably already have the volume. It could give you the mass. But in stoichiometry, remember that it's more important, the questions that are going to be given to you this time are more likely going to be from this side of the looking glass. So it could give you moles there. That would be pretty easy because you just got to cross one bridge. It could give you mass. It could give you volume. It could give you molecules. Any of these things are solvable because you'll just unit convert it to here, and then plug this number and this number in to calculate your concentration. So it's kind of like a little bit of a puzzle, where if you're solving for concentration, you need that. But more often than not, too, the concentration is the one that will be given to you. And so you could start here at volume, and you could end way over here at atoms. Whoops, sorry. You could end way over here at atoms, and like you could start way up here at volume, end way over there at atoms, and you could use this concentration bridge. Depends on what's given to you. You could also, if you were given density, go around, but usually you're not given density very often. Anyway, so going back, you're going to remember that you can solve for a bridge. And so again, here is a, whoops, that 2 is not supposed to be little. Sorry about that. Here is a balanced chemical equation, except that 2 is supposed to be a coefficient. And the mole ratios look pretty easy. It's just 1, 2, 1, 1, 1. And again, here is the question about it. What volume of CO2 at STP? And then it gives you a concentration. Notice it gives you at STP and it gives you a concentration is reacted. So again, let's go back to this bridge for a second. Let's pretend that this side over here is our CO2, and this side over here is our other chemical. I can't even remember what it was now. HCl, that's right. Whoops. So again, our this is our CO2, and this over here is our HCl. So remember that where is it starting us? Well, it's starting us with a certain, it's asking what volume of CO2, I think, and it's giving us the concentration and a certain volume of HCl. So it's starting us with a volume of HCl. It gave us the concentration. Check. And we are trying to find out the volume of CO2. And now notice it said STP. Sorry for my messy writing. So we are going to end up using this 22.4 liters one, not the concentration one here. Okay, so you're starting with volume. You're going to, how many bridges are we going to have to hop? 1, 2, 3 in order to get to volume. So let's check it out and see if we can do that effectively. So again, the planning, I didn't start this question properly. I apologize. I just didn't have room on the screen. So again, I started with my volume, you can see, of HCl. Okay, and I multiplied it by the concentration of HCl, and now I'm at the mole bridge. Sorry, at the moles of HCl. Now here, the mole ratio is where I cross the moles bridge. Now I've deleted, you see the HCl on the bottom, and I'm now in moles of CO2 on the top. Okay, and then here I use the 22.4 to go from the moles of CO2, which are now gone, to the liters of Cl2. So right from the beginning, everything cancels. You have the HCl here and here canceling, the moles canceling. Now notice here that I wasn't specific, and that's because I was typing it out, and it's frustrating to type it out quickly, but I'm really a stickler for having to type out moles and moles of what, because before moles was okay, the unit for moles is okay, but now we don't know if we're talking about moles of CO2 or H2 or HCl. So I should have typed moles of HCl there, but I couldn't because I couldn't fit it all in one line. So you got to watch out for that. So HCl cancels, moles of HCl technically would cancel, moles of CO2 cancel, and you're left with liters of CO2. So you've unit converted all of this from the start right into liters of CO2, which is good. You should get 0.077 for that, by the way. Okay, so that was an example of using concentration. Again, it's the same thing, just using that concentration bridge. Here's another balanced chemical equation. Lucky that it's balanced for us. We don't have to do any work here. Okay, so there's the bell. And here the question is kind of interesting because we don't know the concentration. So going back to our mole bridge in just a minute, the concentration is an unknown. And in fact, we are going to have to calculate the concentration of this unknown acid. But it gives us the volume of the acid. So you can pretty much think right now, well, if it gives us the volume of the acid and we want concentration, we better know how many moles are in it, right? So that's sort of a foreshadowing. Okay, so but we do know that it happens to react with 25 mils of this KOH, where we know the concentration. This is called titrating. It says it in your book. There's a little top of page 130. It explains what a titration is. Titrations are important for both Chem 11 and Chem 12. And when I get back, I'll help you out a little bit more with what a titration is. But basically, a titration is when you take a certain amount of a known chemical with a known concentration, and you react it with a certain amount where the volume is known. See, the volume is known, but the concentration isn't. And so what you're doing is sort of a little problem solving to figure out what was the concentration in this acid. And people use this for all sorts of stuff, like, oh, how much alcohol was in his blood when he died, or how much what's the acidity of my pool, things like that. And you can use titrations for a whole bunch of different things. Anyways, so in this we're supposed to figure out what's the concentration of this acid. Okay. So let's just review with this mole map again. We have, on one side, we have some KOH. I'll just put that over here, KOH. And on the other side, we have this acid, H3PO4. And that'll be our mole bridge sides for now. Notice that it told us the volume, check. It told us the concentration, check, for both of these, for both of this substance. But for this substance, it didn't. It left one thing blank, and that was the concentration. So that's really what we're going for. We are trying to find what the concentration is of H3PO4 right there. Now, luckily, it also happened to give us the volume. Check. Okay, so notice that, again, to find the concentration, we have to surround it. And so the volume and the moles are needed. We have the volume, check, but we don't have the moles. And so, again, that's where this comes in. We're given the volume with the concentration. We're obviously going to take the volume, convert it to moles, take the moles, convert it here. Then we'll have both numbers and we can calculate our concentration separately. Okie dokie. So let's take a look at what that looks like. You can see here that I have taken the initial volume, okay, and again I multiplied it by the concentration, but instead of putting capital M, I put moles per liter, so that cancels the liters off, okay. And then I have, again, for space reasons did not say moles of what, which is a big no-no. You need to make sure that you put moles of what. In this case, it's KOH. I should have put there, okay. And so the moles of KOH here cancel with the moles of KOH. Whoop, not the 2. But the moles of KOH there. This 2 is still important. Then you can see that the moles of H3PO4 would cancel. Oh, no, sorry, that would not cancel. How do I unerase something? Okay, that would not cancel. And then all you have to left to do to figure out the concentration, you notice that I just sort of tacked on a conversion factor here with liters on the bottom. Again, I was unspecific, but it would be, this is 0.0189 liters of H3PO4. Notice too that I also threw in the conversion factors in there instead of putting the 1 to 1,000 blah blah blah. I just put the I just converted those in my head with metric conversions. So then what are we left with? Well, we're left with H3PO4 on the bottom and moles of it and liters on the bottom. So we are left with concentration because all the other units have canceled. So we're left with the concentration of H3PO4, and according to the math, there's the answer. So there you go. There's how the mole map can be used to figure out concentration of things. Bet you never knew that you could do all of this. Okay, so these are the assigned work. Have a good one.